hold on. So we're going to be learning about a lady named Katherine Johnson, and we're going to see how she helped moon exploration. Now, I know last year some of you read A Computer Called Katherine with Miss Pilo. We're going to read a different book this year about Katherine Johnson, okay? And this one is called Counting on Katherine, How Katherine Johnson Saved Apollo 13. Now, the first men who walked on the moon, Neil Armstrong, that was on mission Apollo 11. So this was 2 missions after, but we're going to learn a little bit about what led up to that, okay? And then I have a little activity for you guys afterwards, okay? Miranda, did you have a question?
I actually wanted to say that Katherine Johnson is a family friend that we have.
So awesome.
A friend of my grandpa's.
That's really, really cool. All right, here we go. All right, I'm gonna scooch this up so you guys can see it. Hold on real quick. And save your questions and comments until the end. And I will, we can stay on and talk about those. All right, so Katherine, counting on Katherine, how Katherine Johnson saved Apollo 13. Katherine loved to count. She counted the steps to the road, the steps up to church, the number of dishes and spoons she washed in the bright white sink. The only things she didn't count were the stars in the sky. Only a fool, she thought, would try that. Even so, the stars sparked her imagination. What was out there? Katherine yearned to know as much as she could about numbers, about the universe, about everything. Katherine's boundless curiosity turned her into a star student. She was so bright, she skipped 3 whole grades. She catapulted right past her brother. He wasn't too happy about that. Now, if you have a younger brother or sister, how would you feel if they jumped into 4th or 5th grade ahead of you? Or how would your older brother or sister feel if you jumped right in front of them? Probably not too good. I don't think her brother liked it either. By the time she turned 10, Katherine was ready for high school. 10 years old going to high school. But back then, America was legally segregated by race. Her town's high school didn't admit Black students of any age. Now just imagine that. She's going to high school at 10 years old because she's so smart, and they won't let her in. How sad. Katherine burned with fury. She wanted more than anything to keep learning. There was still so much to know. Count on me, Katherine's father told her. By working night and day, he earned enough money to move the family to a town with a Black high school. Katherine loved high school. She was good at every subject, but math was still her favorite. She dreamed of becoming a research mathematician, making discoveries about the number patterns that are the foundations of our universe. In those days, though, there were no jobs as research mathematicians for women. Professions most available to them were teaching and nursing. So Katherine became an elementary school teacher. She liked her job and she loved her students, but she never stopped dreaming about exploring numbers. In the 1950s, the U.S. government's National Advisory Committee on Aeronautics, or NACA, hired thousands of new employees. It even started hiring Black women as mathematicians. Katherine heard about the mathematician job. Her heart raced with excitement. Perhaps her dream could come true after all. But when she applied for one of the positions, she was told that they were already filled. Katherine had to wait a whole year until new spots opened up. Her patience paid off, and she got the job. And this is at Langley Aeronautical Laboratory in Hampton, Virginia. So that's right across the bridge from us. A few years later, the Soviet Union sent a rocket ship into space, launching a space race with the United States. NACA was rolled into a new space agency. We know this one, the National Aeronautics and Space Administration, or NASA. Katherine now found herself at the heart of America's space program. She worked as a computer. Electronic computers were not widely used yet. Calculating long series of numbers, all the computers were women. They were given the tasks that men thought were boring and unimportant. That didn't bother Katherine. She knew that without her contributions, a spaceship couldn't reach its destination, nor safely return to Earth. So she knew how important her job was. Here's why. Sending a rocket ship into space is like throwing a ball into the air. At first, the force of the throw sends the ball up, up, up. But as its energy runs down, the ball's path curves back toward the ground. Where it lands depends on what angle it was thrown and how high and how fast it flew. Because math is kind of a language, Katherine could ask those questions. How high would the rocket ship go? How fast would it travel? Using numbers, and numbers would provide the all-important answer. Where would it land? To find out, Katherine plotted the numbers she'd calculated on a graph. When she joined the points together, they formed a curved line. At one end of that line was Earth at the time the rocket ship launched. At the other end was where where Earth would be when the ship landed. Katherine's reputation for accuracy and strong leadership skills, she was known for asking plenty of questions, got her promoted to Project Mercury, a new program designed to send the first American astronauts into space. Mercury's missions were going to be dangerous, so dangerous that even the project's star astronaut, John Glenn, refused to fly unless Katherine okayed the numbers. You can count on me, she said. Glenn's spacecraft Friendship 7 orbited Earth 3 times and returned home safely. Glenn became a national hero. So she helped get the first man into space. Katherine was promoted again. Now she was asked to calculate the flight paths for Project Apollo, the first flights to the moon. Count on me, she said. On July 20th, 1969, the Apollo 11 astronauts walked on the moon. Their feat was celebrated around the world. More triumphs followed. Apollo 12 rocketed to the moon in November 1969. Apollo 13 launched on April 11, 1970. But on the third day of Apollo 13's flight, the worst thing happened. An explosion in space. Could the crippled spaceship make it to the moon? And if it didn't, would it be able to get back home to Earth? The 3 astronauts on board were in grave peril. Commander Jim Lovell told Mission Control, Houston, we've had a problem. So this exploded in space, but there's 3 astronauts on it. And they're not going to be able to make it all the way to the moon. Back on Earth, Katherine Johnson got a phone call. Her flight path calculations would have to be done all over again, and perfectly. It would be the toughest challenge of her life. Katherine told Mission Control, you can count on me. She rolled up her sleeves, took a deep breath, and began doing the math. She worked hard and fast. A few hours later, Katherine's calculations were finished. The flight path to return home would take the ship around the far side of the moon. From there, the moon's gravity would act like a slingshot to zing the ship back to Earth. To get home, the crew of Apollo 13 would have to follow Katherine's course exactly by burning off fuel at precise intervals. If the astronauts made a mistake, their ship would drift through space forever. Katherine waited anxiously to hear the astronauts' report. Finally, it crackled over the loudspeakers. We've got it! Apollo 13 was back on track. Katherine Johnson had done it. She'd brought Apollo 13 home. She was no longer the kid who dreamed of what lay beyond the stars. She was now a star herself. All right, so she helped the first man get into outer space. She helped the first crew land on the moon and walk on the moon. And then on Apollo 13, where it exploded in space, she was able to recalculate and to save the crew. And they returned home safely, which is pretty impressive. So without Katherine Johnson, who knows what our moon explorations would be like. Now, she did the trajectory. She figured out how to go to the moon, what angles, how fast it had to go. She did all the math for that. So I'm going to have you guys do a little experiment today. So what I want you to do is grab a piece of paper, if you've got one nearby. It can be a plain piece of paper. It can be a colored piece of paper. And guys, I'll answer your questions at the end of class, okay? So just hold on a few more minutes. All right. You guys have a piece of paper? Let me see here. All right. With your piece of paper, we are going to be making a paper airplane, okay, to do our experiment today. Now, we are going to make an airplane that looks like this. If you have a favorite kind of airplane that you know how to fold, go ahead and do that. But our goal is to make it go straight. So if you know how to make one that does cool flips and turns, this isn't a good one for that, okay? So I'm going to hopefully get this to where you can see this table, maybe. All right. Can you hear the pounding? They're putting solar panels on the roof and it's very loud. All right, so with your piece of paper, the first thing you're going to do is fold it in half lengthwise, okay? So fold it in half up and down. And I can't see you guys, so if you have questions, I'm sorry I can't answer them right this second, but stay on at the end of class. And I'll also post this video so you can try to remake it again. And I do have on my Clever page some airplane folding videos and tutorials that you can always look at. Okay, once it's in half, you're going to open it up and you are going to make a point. So this part is going to go to the center line to make a triangle. And you'll do that with the other side too. Okay. So it kind of looks like a little roof on the house. Okay. Next, we're going to fold it in half. But so these little flaps are going to be on the outside. So fold it back on that line. You have what looks like this. And a tip for paper airplanes, the sharper you make those creases, the better it flies usually. All right, next, we're going to take this curved part and you want to fold this curved part so that it lies flat with the bottom. Okay, so I'm taking this diagonal angle is going to go flat with the bottom. I'm going to put it down so I can fold it better. And then you're going to flip it over and do the exact same thing on the other side. So now it's going to look like this. It's kind of funny looking. Okay. We've got one more step. Now we're going to take this long diagonal and we're going to fold that down to the bottom. Okay, so watch. I'm going to take this long diagonal and fold it down to the bottom. And I'm going to do that on both sides. Okay, I'm gonna flip it over and I'll do it again. So it's going to look like this. All right. What I'm going to have you do for your experiment today is to figure out which angle an airplane is thrown that will get it the farthest. Okay. So you're going to try 3 different angles. I'm going to write this on the board and we'll make a prediction before you do it. And you'll probably do this on your own because it's going to be too hard to do it all together. But the first one you're going to do is at a 0-degree angle, which means you are going to throw it straight ahead. Okay? 0 degrees is straight ahead. I'll go this way since I'm going that way. All right. The next one we're going to do is a 45-degree angle. Okay? Which is kind of diagonal up. Okay? And then the third one we're going to do is a 90-degree angle, which is straight up. Okay? So you're going to throw your airplane 3 different times. And if our goal is for it to go the farthest, do you think you want to throw it straight ahead at a 0-degree angle, kind of halfway angled up at a 45-degree angle? You're going to get more height that way. Or do you want to throw it straight up? Okay. If you don't have a paper airplane, you can try this with anything. If you have a ball, you could try throwing a ball straight ahead at a 0-degree angle, at a 45-degree angle, or straight up for a 90-degree angle. Okay? You could make a tape ball, a foil ball, anything like that. Anything that you have that you can throw in the house or outside if hopefully it's not raining. Okay? So before we do this, let's make a prediction. So what I want for you to do is I want you to predict if your plane will fly farther at a 0-degree angle, at a 45-degree angle, or at a 90-degree angle. What angle will it go the farthest? So first of all, who thinks, just raise your hand if you think that it's going to fly farther at a 0-degree angle, straight ahead. Just show me your hand on the screen. Okay. I see lots of hands there. All right, hands down. What if you throw it at a 45-degree angle? Who thinks it's going to go farther at a 45-degree angle? Kind of slanted up. All right, I see some hands. All right, and who thinks, go ahead and put your hands down. Who thinks that it's going to fly farther if you throw it straight up at a 90-degree angle? Who thinks it'll go farther if you throw it straight in the air? All right, I see some hands. I don't see as many hands, but I do see some hands. All right, so what I would like for you to try to do today at some point, I know some of you are in a room that throwing an airplane is probably not the best idea, so don't do that and get yourself in trouble. But if you can find a space today to try out this experiment, I would love that. And then come back tomorrow and tell me which way it flew the farthest, okay? So Katherine Johnson had to do a lot of math to figure these things out, because if you think about it, the Earth is always spinning, right? And so when we are launching off of that, they have to take that into account because it's always moving. If they're going to the moon is always going around us, so that's moving too. So everything is constantly moving in outer space. So they have to figure out exactly when you can launch and how high and how fast. And she helped make that possible, which is really cool. I'm gonna let those of you who are done and ready to go do your experiment, I'm gonna let you go in just a second. But for the rest of this week, we are going to be looking at astronauts who live in outer space permanently. And we're going to look a little bit at the Mars lander and how that worked. And hopefully we'll have some updated information from Mars, which is pretty neat. So we'll be doing a little bit more space exploration today. I will give you another building challenge if you choose to do tomorrow after class, okay? So thank you so much for coming. For those of you who have questions or comments or want to stay and chat, go ahead and do that. For everybody else, have a fabulous rest of the day. And I'm so happy you came. It's so great to see you. All right. Bye, guys.